All right, class, today we're going to look at section 5-6. And section 5-6 has to do with our second special pattern that I'm trying to get you to recognize to help you as we go through our journey through quadratic equations in chapter 5. So if you look, this one is called the square of a binomial. Okay, Mrs. Burton sometimes calls it a binomial squared. All right, and so the idea is, how would I multiply a plus b parentheses squared? Now remember, whenever we see that exponent up there, that tells me how many times I repeat the base. So this really means a plus b times a plus b. Okay, that's what it means. Now, so we're back to foiling or distributive property or the box method, whichever you prefer. Now we're going to see that there's actually a special pattern here that you can memorize, which will help us go a whole lot faster as we look at these binomial squares. Okay, so let me get rid of here. And now, if we look here, all right, how would we write that as a product? Now remember, product means multiplication. So if we went to the old-fashioned way, okay, and foiled it, we'd have a plus b times a plus b. And then if we foil, all right, well, F stands for first. A times a is a squared. Outside, well, that's going to be ab. Inside is going to be ab. And then when we multiply the last, we get b squared. So we end up with a squared plus ab is 2ab plus b squared. Okay? And so that's what we're going to see when we're adding. Now, what would happen if we're subtracting? What happens if it's a minus b squared? Well, once again, we're going to find out if I went ahead and I used my FOIL method as I go through here, then we would see, gotta get my, okay, we'd see that if we did FOIL, first is a squared, outside is negative ab, inside is negative ab, and last, negative b times negative b is positive b squared. And if we collected our like terms in the middle, we'd have a squared minus 2ab plus b squared. So if you look, the special pattern is almost the same except for one sign. Now, let's see what this means for you and I. Okay? First of all, how do we know we have a perfect perfect square binomial? Well, here's what it says. A perfect square is any quantity that can be written in the form parentheses squared. For example, 25 is a perfect square because it can be written as 5 squared. Here's another example. Now we're looking at a perfect square binomial, and here's the explanation. Now, it's going to be a little bit hard for us to see there, but if you look, we have to take the first one and square it, and then it's 2 times 3x plus 3 squared. And so we're going to see this pattern come up over and over and over again. So here's what it's going to look like. Patterns of perfect square binomials. Now, here's how we're going to apply it, and I'm going to show you on the next slide. But if you can memorize this pattern, it's faster than foiling. Now, I've got to say this. Let me go to the next slide. Some students look at number 1, and they say, oh, that's z squared plus 64. Okay? That's a big bozo no-no. You cannot say z squared plus 64. Okay, because you've only multiplied the first and the last. You forgot about the middle, so we can't do that. We've got to follow the pattern. Now, for the first one, it's plus. And here's what the pattern is. We look at the first term. Okay, this is considered A, and this is considered B. So we look at the first term and we square it. Okay, so what's Z squared? Z squared. Okay, now the middle is plus 2AB. What does that mean? Well, we're going to multiply Z and 8 together, which is 8Z, and then we double it, which is 16Z, and then we square the last one, B, which is 64. And once again, it looks super weird, but if I can get you to understand the pattern, it will save us a ton of time later on as we get through this journey of chapter 5. All right, so let's look at number 2. Number 2, we've got the minus sign. All right, remember this is A and this is B. And if we look up here at our special pattern, we take the first term and we square it. Well, what's 3y squared? Yeah, that's 9y squared. Now, we take these two guys and multiply them together. That's going to give me negative, okay, that's going to give me negative 24y. And now, remember, we have to double that, which would be negative 48y. And then we take the last one and we square it, and we get 64. So you take the first one and you square it. Let's see, is there another one down here? Let's try another one. All right. So this is A and this is B. So we take the first term and we square it. What's 5A parentheses squared? Well, that's going to be 25A squared. Now, remember, we multiply these two guys together. 8 times 5 is 40AZ. And now we've got to double that because of the 2AB up here. So that's going to give me negative 80AZ. And then we take the last one and we square it, plus 64Z squared. Let's try one more and see what happens, okay? All right, so we've got to take this is A and this is B. We take the first term and we square it. Well, negative 6 times negative 6 is 36. And then we're going to have R squared, S squared. Now, remember, we multiply these two guys together. That's going to give me negative 6 RS cubed. Remember, we've got to double that for the 2AB, which is negative 12 RS cubed. And then we take the last one and we square it. Well, S squared is 4. So it's going to take a little bit of time, okay, to get through and memorize the pattern. But once you get it going, it saves a lot of time as we go through. Well, that's going forward, okay, that's going forward. That's where they want us to multiply and learn these special patterns. Now, what happens when we have to go backwards and they want us to factor? Now, the first thing we have to figure out is when they give me my trinomial, okay, we've got to decide, is that trinomial a perfect square? Well, we have 3 questions to ask ourselves, okay? First of all, you got to make sure that it is a trinomial, which means we have 3 terms. Now, is the first term a perfect square? Well, when I look up here, is x squared a perfect square? Yes, it is, okay? And then I've got to look, is the last term a perfect square? Well, when I look up there, that's 64, and yes, it is, okay? Now, here's where we've got to go back and check the middle, okay? We've got to check the middle term, and if the middle term checks out, then we have a binomial squared. So what do we mean by checking the middle? So when I look up here, and I'm going to go ahead and write it down, I've got x squared plus 16x plus 64. Here's how I kind of do it. I look at the first one and say, oh yeah, that's a perfect square, okay? And then because both of these are plus, mine's going to be plus. And then 64 is a perfect square, that's 8. Now, here's how I check the middle. Remember, we multiply these two guys together, which is going to give me 8x. And remember, we've got to double it to get that 2ab, and that gives me 16x. Well, guess what? My middle checks, and so this is considered a binomial squared. Gotta let that sink in for a minute. Okay, let's go try a few. So it says, decide whether each polynomial is a perfect square. If it is, factor it. And if it's not, write not a perfect square. All right, so here's what we do. Remember, we got 3 questions to ask ourselves. Is the first term a perfect square? Yes, it is. So I say the square root of a squared is a. If this is a minus sign, I'm going to have a minus sign. Okay? Is the back term a perfect square? Yes, it is. What times itself gives me 4? That's 2. All right, now, I've got to check the middle to see if it's a perfect square. So how do I check the middle? Remember, we're checking to see if we've got 2ab. All right, that's what we're checking for. So we've got a times negative 2 is negative 2a. And if I multiply that by 2, I get negative 4a. The middle checks. Okay, if the middle checks, then this is a binomial squared. Let's try another one. Let's look at number 2. That you notice this isn't difference of perfect squares, first of all, because there's 3 terms, and that's a big difference. So I've got to look. I've got my 3 terms. I've got a trinomial. Okay, is the first term a perfect square? Yeah, it is. What's 3m? If I multiply 3m by itself, I'm going to get 9m squared back. I got a minus sign first, so that comes here. What's the square root of 4? All right, there we go. Okay, now we've got to check the middle. So remember, to check the middle, I'm going to multiply these 2 guys together, and we're going to get negative 6m. And if I multiply that by 2, I get negative 12m. So the middle checks, and this is a binomial squared. Let's look at number 3. 3 terms. So I'm checking to see if it's a binomial square. Is my first term a perfect square? It is. Square root of 144 is 12. This time we got a plus sign here, so we're going to put plus. And that's going to be y. Okay, the square root of y squared is y. Now, let's check the middle this time. Remember, when I multiply these together, it's going to be 12y. And I've got to multiply that by 2, which is 24y. And this time, the middle doesn't check. So this is not a perfect square. Okay, and I know it seems kind of funny checking the middle, but as soon as we're going to start doing that a lot as we go through, this is just the first time we've seen it. Okay, now look at number 4. You got to look at it and say, well, that's a perfect square, 9's a perfect square, but 24 is not. And then you say, hey, wait a minute. That's not in the right form. So let's rearrange the furniture. Let's put it in quadratic form. Remember, the quadratic term goes first, and then the linear term goes in the middle, and the constant term goes on the end. All right, so now that we have that in standard form for let's see if we've got a binomial squared. So let's look at the first one. Look at the first term. Is the first term a perfect square? Well, when I look there, it's 16c squared, so that's a perfect square. Okay, 16tc squared is a perfect square. So let's go ahead and write down 4c. Again, I got a minus sign in the middle, so there we go. Is 9 a perfect square? It sure is. We're going to put 3. All right, now let's check the middle. We've got 4 times 3 is 12c. If I double that, we get 24c. The middle checks. So this is a binomial squared. Okay, you kind of getting the picture here as we go? All right, we're going to go ahead and do some more problems together on our worksheet with a partner. So go ahead and pull out your worksheet, and we'll continue there.